Alright guys, so I gave you guys a little video tutorial yesterday on finding the distance in the coordinate plane, and some of you guys did very well, and then some of you said that you couldn't follow this video at all. So I wanted to go ahead and do a little tutorial myself. You can take notes with me as we go so that you can use them for the worksheet I post later on. So I just went and labeled it lesson 14.1 distance in the coordinate plane and put the little date. So you can do the same thing. And remember, you can pause this at any time and go back and stop or listen to what I say as we go. Okay? All right, so I'm just going to go ahead and start. The first thing I want you to know is the word reflect, like your reflection in the mirror. Of course, your reflection is you're seeing the exact same thing of you in the mirror. Okay? So I want you to think of that with a coordinate plane. When I say to reflect it across the axis, it's going to be the exact same distance across the same axis. So I want you to draw a grid. And sorry, I'm holding this, so if it shakes a little bit, I'm sorry. I'm trying to write and do this at the same time. Draw a little grid. Okay. Now remember, this is the y-axis. It runs up and down. This is the x-axis. It is running horizontally. And let's just label it maybe through 10. One, two, three. We'll do that for all of them. Remember, these are all positive. I'm not going to label every one because you guys know. This is negatives. And negatives. Alright. And there's our negative one. Remember, that's our origin. Okay. So, it is super important that you know this is the y-axis. Anything that runs this way is going to be on the y-axis. The second number of our ordered pairs is always the y-coordinate. So if I had the ordered pair, I don't know, let's say 3, -2. All right, when I go to plot that, we go over 3, that's our x-coordinate. Remember, this is always our x. This is always our y. X always comes before y, right? In the alphabet. So I'm going to go over 3. Then I'm going to go up or down. Of course, it's going to be down, -2. So over 3, down -1, 2. I'm going to plot it right there. All right, there's our point. Now, what I want you to do is if I said, reflect this point along the x-axis, when you reflect it, is going to be the same distance across on the x-axis. We're flipping it across the x-axis. So when I say flip it across or flip it on the x-axis, you're going to flip it and be on this side of it now. So if you went 3, -2, we're staying on the x and we're going to go 3, +2. So 3, 1, 2. Right there. It is still on the same y, or x, I'm sorry, but we flipped it, okay? All we did is reflect it. So the distance from here to here is 2, and the distance from here to here is still 2. If you don't remember this, I'm going to write this down and see if you remember it. Boom, boom, boom. These are called absolute value. We talked about them a lot in the beginning of the year. And the absolute value just means the distance from 0. Okay? So the distance from this point right here, 3, 2, I'll write that. Its distance from 0, which is, this is 0 right here, this line, is 2. So the absolute value from this point to here is 2. And the absolute value from this point to here is 2 because we went 3, 1, 2, negative 2. We went down 2. Still, it's going to have an absolute value 2. If you remember, absolute value can never be negative because it's distance. You can't have a negative distance. Okay, so let's pick that same point. And let's say we have 3, negative 2 again. I'm right here at 3, negative 2. And I said, let's reflect it across the y-axis this time. So instead of reflecting it across the x-axis and going across the x, we're going to go and flip it along the y-axis, kind of like a line of symmetry. If you were to fold this paper, and I folded this paper and I flipped it, that point would be the same exact distance across from this y-axis. So let's think about it. If we went 3, negative 2, I want to go across this way. So I'm going to say, okay, if it's 3 away from this 0 here, 1, 2, 3, I need to go 1, 2, 3 this way. And then I will still be on the negative 2. I'm not changing my other coordinate. I'm just flipping. I'm literally doing like a line of symmetry. So if it's starting at the 0, remember absolute value to this 3 is 1, 2, 3. I'm going to go 1, 2, 3, and I'm still keeping it on the negative 2 line. Right there. So now our reflection across the y-axis is 1, 2, 3, negative 3, still negative 2. All we did is flip it across this axis now. So the first one I did, I reflected this point, 3, negative 2. I reflected it. I'm going to write this down. Reflect across x-axis. And remember, when we did that, we just did the same distance that it took to get from that 0. It took 2 there. So we wanted to make it take 2 there. We did not move it left or right. We just flipped it across this one. Boom, like I were to fold this paper in half. And we're still at 3, but now we're at 2. So our point is 3, 2. But then we did the same point, 3, negative 2, and we said let's flip it across or reflect it across the y-axis. And when we reflect across the y-axis, we did not change the coordinates of the x. We only changed the coordinates of the x. So when we flipped it across the y, we said, okay, it went from this origin here. This is 0. It took us 3 to get there. So it's going to take us 3 to get that way. I need to go 3 that way. So that would be negative 1, negative 2, negative 3. I'm staying on the same line. So it will be negative 3, negative 2. That is when we reflect it. So I should be able to have the same distance here as I do here from this line. We're always using that line as our line of symmetry. Okay? When it looks in the mirror, it should be the same distance away from the mirror here as it is from here. Or if it was looking at this x-axis mirror, it would be the same distance from here as it is from here. Okay? That's the first part. Now, I'm going to move on to the next part, okay? So let's keep going. Remember, you can pause this. I want you to take notes as we go, so have paper. All right. Now I want you to kind of look at this. I'm using our math book. This is finding distance, and this is where some of us had a problem. Let's look at this example. It says, what's the distance between point A and point B? Here's point A at 4, 3. You can see it's 4, 3 because 1, 2, 3, 4, up 1, 2, 3. All right. You always want to be thinking, how can I get to the axis? Okay. So you want to look, where's my point B? Point B is right here. See that B? it is 4, -2. So they went over 4, down -2. To get from here to here, I need to know my distance. So first you get yourself to that axis. You want to get yourself to that axis. So you just count the squares, basically. You can go, okay, 1, 2, 3. It took me 3 units to get to right here. Remember, that's absolute value. So they will write it as the distance of that is absolute value of 3, which of course is just 3. We know what absolute value is. Now, I still got to get to that point right here. So now I'm here. Let's see, from this point, I'm starting back at 0. How much did it take me to get from this to this? Let's see, 1, 2. That took 2. That is also called the absolute value. That's the absolute value of 2. Now, all we do to find the distance is we add those 2 together. Well, the absolute value of 3 is always 3. Remember, it can only be positive. And the absolute value of 2 is 2. Now I just add it. So our answer is 3 plus 2, which gives us 5. So the distance between A and B is 5 units, okay? Now if we look and it says, what's the distance from C to D? Okay, now we're traveling left and right, all right? We don't have an axis to get to. We see that C is at -1, -4. We want to get to D at -5, -4. Notice they're on the same x-axis. All we're doing is traveling and counting how many squares it takes us to get there. So let's count. 1, 2, 3, 4. It took 4 squares between those. That's also just called the absolute value of 4, which is just 4. Boom. That is finding the distance between points. Okay? So when you did these ones, how'd you do these for your work yesterday? Yeah, you probably had to draw a grid. So like for number 3, it says find the distance between E is -4, and F is 5, 7. So I'm going to draw a grid over here. This is number 3. Draw a quick little grid. It doesn't take you long. You can even do, I'm just going to do to like 5. And that's the Y, that's the X. Okay. It said that E was -4, 7. So I gotta go -1, 2, 3, 4, and it was 7. So I'm gonna have to go a little bit more. I went 1, 2, 3, 4, 5. I gotta go to 7. So -4, 7 is right here. That's E. And I'll write it down again. All right, and then it said F is 5, 7. So we want to go 5, 7, 1, 2, 3, 4, 5, up 7, which I remember is that top one right there. That's F. And that's 5, 7. Now we want to find the distance. Now, as you can see, what do you notice about their coordinates? They have the same Y coordinate of 7. That's because they're on the same plane. They are both right here on the 7. All we're doing is traveling across because our X changed. So we just want to know how far from here to here. We're not moving left or right or up or down. We're just going across. So remember, make your way to that axis first. You know that this is at -4. So we're going to count till we get to this axis. So -4, we can even count backwards. -3, -2, -1, 0. So to get from here to here took a total of 4. That's also just the absolute value. That's the distance, which of course, absolute value 4 is still 4. Then to get from there, we still got to get way over here to this 5. Well, we know from this point, this is 0. We got to count over to 5. Well, that's 1, 2, 3, 4, 5. So from here to here, it is 5. Or also known as the absolute value of 5. Absolute value 5 is just 5. Always positive. So to find the answer, all we do is add the amount we counted from here to here, and then from here to here. So 4 plus 5, and our answer is 9. That's our units, okay? That's all we're doing here. Not too shabby, not too hard. I think that should do it for this one. Trying to see if I'm gonna do one more, hang on. All right, let's just try one like this. The point 5, -2 is reflected across the x-axis. What are the coordinates of the reflection? So first thing you need to do is draw a grid. It can be quick. It can be small. I'm gonna say, okay, I know 5, -2, so I've got to at least go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm gonna grid that in 5, -2. So I'm gonna go over 5, down 2. I'm right about there. Now remember, if we reflect it across the x-axis, this is the y, this is the x. We're going to reflect it across this one. So it's going to find its reflection on the other side of the x. We are not reflecting across the y for this one. It just wants across the x. So if we reflect it across this is our little line that we're going to flip it and do our symmetry. If we know that this is 5, -2, it's going to stay on that 5. Now we said, okay, it takes 2 to get there, right? From here to -2, it's 2. So all I want to do is go from here. I want to go 2 up. Instead of going 2 down, I'm going to go 2 up. So I'm going to go, okay, wait, 5. Oh, 2 up, 1, 2. My coordinates would be 5, boom, boom, 2. Does that make sense? So that would be our answer there, 5, 2. Now the next one says the point -6, 8. So let's go -6, 1, 2, 3, 4, 5. I'm gonna do one more, -6, and then 8. So it's gonna go up 8, 1, 2, 3, 4, 5. I have to go up a little bit, 6, 7, 8. So -6, 8 is gonna be right about here. We want to reflect it across the y-axis this time. So that means now we're going across this guy. We want to take him and flip him across that mirror. It's like a little mirror, and have it be the same distance from there to there as it is over here. So it's going to be exactly across from it, but now it's going to be on this side because we're flipping it across the y-axis. So that means keep it right here on the 8. We're not moving that 8. We're only moving this part. So to get from that axis to here, we know we had to go -6. So from there to there was 6. That means we have to do the same thing this way. We have to go 6 this way. So if I'm starting at 0, of course, 0, 6 that way would put us at 6, 8. We would still be at 6, 8. Okay? Let's see. I think that's pretty good. All right, let me get another piece of paper and we're gonna do another part of our lesson. You can pause this and that's your notes for this one.